New definition here, the unit vector. And anytime we use the word unit, we're talking about one. So what we're looking for is a vector in the same direction as another vector, but whose length is 1. Because sometimes you have a vector, you like its direction, but you want to do something else with it. You want to make it longer, you want to make it shorter. So you find the unit vector, and then once you have a unit vector, if you want to make it a length of 3, you could just times your unit vector by 3. So here we're going to find the unit vector in this direction. And there's a number of different ways that we can write our answer. So first of all, this vector u, we can first figure out how long it is, because who knows, it might already be a unit vector. I have doubts at this moment, because I don't think this is going to have a length of 1, with the first number being a 6, but you never know. So we got 36 plus 9 plus 4. Oh, it's this pretty one that has a length of 7. So our vector has a length of 7. We want to write a unit vector that has a length of 1. So all we would have to do to our vector is divide it by 7. So the unit vector for this one way to write it is, there's our vector 6, negative 3, and 2, and we could divide it by 7, because then its length would be 1. You could also write it with the I, the j, and the k. Can you see what would happen if we added the 7 on the bottom of each thing? That when we would go to find the length, we would have divided by 49, divided by 49, divided by 49. And you already have a common denominator, and all the top would still add up to 49. But now that's going to get divided by 49, so you're going to get 1, and the square root of 1 would be 1. So another way of writing it would be with the I, the j, and the k. You could also write our unit vector here in this form, but just put that 1/7 inside. So the strategy to find the unit vector, find the length of the vector that you're working with, and then you just have to divide by that length to find your unit vector. So try these two. All right, did you find that the length of u was the square root of 29? And that the unit vector for u then would be, well, one way to write it would be 5 over root 29I minus 2 over root 29j. Or you could write it like that, or I tend to like this. That last one. Just because it keeps things simple. You can see your vector that you started with. You can see your magnitude and that you're dividing by it. Don't need to rationalize. I mean, you could write it as 29 over root 29 over 29, but that's fine. What was the length of this one? Square root of 61? So then our unit vector would look like that. Yes? because of the little hat? I'm not sure. So now that you've found a unit vector, you can find a vector of any size in the same direction as any other vector. What we're going to do is we're going to find the unit vector first, and then if we want a vector of magnitude root 7, we'll just have to take our unit vector and multiply it by root 7. So I'm going to call this vector u, 5I minus 3j plus 2k. Has anyone calculated the length of u already? 25, 34 squared to 38. So then our unit vector will be 1 over the square root of 38 of 5, negative 3, and 2. And our vector of length 7, I'm going to call it vector v, would be root 7 over root 38 of 5, negative 3, 2. So all we're doing is we're finding out, we've got our direction, and basically this vector right here, that's telling us our direction. And then the number in front just is telling us how much or how far to go in that direction.